NASA has shared pictures of something that has never been seen before. A star called Betelgeuse blew off its top and threw off a huge chunk of its surface mass. The space agency says the ejection was 400 billion times the mass of a normal solar flare from our sun. The event is called a surface mass ejection, SME. Scientists call it watching stellar evolution in real time because it is so unusual for a star to blow off such big pieces of its body. A huge explosion from this super red giant is changing a lot of what we think we know about the world. Why did Betelgeuse's top blow off? What will happen to the universe? Let's find out. The stars in a constellation are arranged in a way that is related to myths and stories. They are still used to find their way around today. Betelgeuse is one of these stars. It is one of the biggest and brightest in the night sky. Betelgeuse is the name of a bright, sparkling ruby-red star that can be found in the upper right shoulder of Orion, the Hunter, the winter constellation. Astronomers, on the other hand, see it as a monster that is boiling over and has a beating that beats regularly every 400 days. Betelgeuse is easy to spot because of its sad orange-red color. It's a great way to show people who don't believe that stars do have different colors. This star is also called Alpha Orionis, and it is the second brightest in the constellation. Rigel is the brightest. Due to its changing nature and strange name, Betelgeuse is an interesting object to study and observe as a star. Most of the time, stars named Alpha are the brightest in their constellations. Even though Rigel, the other bright star in Orion, is brighter, it is Alpha Orionis because of its name, light, size, and reddish color. Also, it's one of the most famous stars. You may have heard that this star was the inspiration for both the character and the movie Betelgeuse. You can see Betelgeuse as the seventh brightest star from most of North America, Europe, and Canada. It is also the 10th brightest star in the whole sky. Earth is not too far away from Betelgeuse. Scientists can't say for sure how far away Betelgeuse is from Earth, but they think it's somewhere between 430 and 724 light-years away. It is the largest red supergiant star and the nearest star to Earth in our galaxy. It has only been possible to name 200 red supergiant stars. The Sun is about 764 times bigger than Betelgeuse in terms of its diameter. This star would be bigger than the asteroid belt and even bigger than Jupiter if it took the place of our Sun in the solar system. This makes it sound like the Earth, Mars, Venus, and Mercury would all be absorbed totally. 16 1/12 times as big as the Sun is Betelgeuse. From 548 light-years away, you can see this supergiant, which has 126,000 times the brightness of the Sun. This star is 3,600 degrees Kelvin cooler than the Sun, which means its surface is cooler than the Sun. About 13.3% of Betelgeuse's radiant energy is light that we can see. It's possible that Betelgeuse would be brighter than Sirius at night if our eyes could see all colors of light. About one solar mass is lost every 10,000 years by Betelgeuse. There is a cloud around the red star because it is ejecting matter in all directions in an uneven way. Betelgeuse is surrounded by a cloud of matter 250 times bigger than this star. This nebula is also thought to be 30 astronomical units across, which is 30 times the distance between the Sun and Earth. This is how far away the Sun is from Neptune, which is the farthest planet in the solar system. The Sun in our solar system often sends large amounts of matter into space. These events are called solar flares, but the Sun only lets out tiny pieces of its upper atmosphere, which is called the corona. This is what coronal mass ejection, CME, stands for. Because of this, surface mass ejections and coronal mass ejections can happen at different times. The corona is the name for the CME that is made when a star throws off some of its unstable outer atmosphere. CMEs from our solar system happen all the time and can affect Earth and the people who live there. CMEs can send magnetic fields and plasma into space at speeds of more than 1,800 m/s. This means that sometimes they can get to Earth in just a few hours. When it happens on the side of the Sun that faces Earth, A CME can damage and disrupt Earth's satellites and power grids. It can also put humans in orbit in danger. The new discovery shed light on the strange reason why Betelgeuse is getting dark. In 2019, the star threw off matter that burst into space, creating a cloud of cosmic dust that kept people on Earth from seeing how bright Betelgeuse really was. Also, Betelgeuse's famous steady pulse pattern has been changed. Betelgeuse's CME was different because it released 400 billion times more mass than a normal CME. This made the star shake like a dish of gelatin dessert. According to a NASA news release, astronomer Andrea Dupree of the Center for Astrophysics says that the star's internal convection cells may be in disorder, while the photosphere, which is what we see as the surface of the star, struggles to reconstruct itself. For the past 200 years, astronomers have been keeping track of the star's steady pattern, but it no longer appears. Red giants like Betelgeuse are all dying, and scientists will be able to learn a lot about how stars change over time by watching this process. Most stars in the universe get their power from nuclear fusion. When this process runs out, the star goes through a number of interesting changes before it finally dies. When a star is first formed, it is made up of hydrogen. Gravity pulls the hydrogen together in the star's core, where it explodes into helium. A lot of light and heat energy are usually given off during the fusion process. This energy moves to the star's surface and is sent into space as a photon. Helium starts to join with carbon to make carbon as the star ages. Hydrogen, the star's main fuel, runs out. When all the helium is gone, neon will finally join with carbon to make iron. When this happens, the energy is not released, but instead taken in by the fusion of light and iron. When iron starts to fuse, there is nothing to stop the star's very strong gravity. As a result, the star falls apart, causing a supernova explosion. A supernova is one of the strongest forces in nature. It can make more energy than 10 billion suns. As stars age, they change color from the newest, hottest blue types to older, cooler red types. The color change depends on what stage of their growth the star is in. It's interesting that the Greek scientist Ptolemy, around 168 AD, said that Betelgeuse's color was reddish, but Chinese researchers had said that the star looked yellow 300 years before. This could mean that Betelgeuse used to be a yellow supergiant. Even though they are only about 10 million years old, bigger stars often use up their hydrogen faster and die off sooner. There's no doubt that Betelgeuse is almost dead. On the other hand, our Sun is only about 5 billion years old, so it is still in its prime. Another thing is that a supernova might happen soon since Betelgeuse is almost done with its life. Betelgeuse goes through 2 rounds of getting darker and brighter. The second one happens about every 5 years and lasts for 100 days. It is thought that the star's outer shell will grow and shrink during this cycle, which will change the star's diameter and average temperature at each stage. Astronomers may learn more about how red stars lose mass in their last few days before they explode in a bright supernova from Betelgeuse's burst. We've never seen a huge mass ejection on the surface of a star before, says Dupree. There is still something going on that we don't fully understand. We can see this brand new effect directly and clearly with Hubble, which helps us see surface features. We're seeing the development of stars happen right now, but because the results are so strange, it's not clear if this means that Betelgeuse is about to go supernova. An alert from NASA says Betelgeuse might not be dead even if it seems like it is. NASA says that red supergiants die very quickly compared to the rest of the universe. In 100 years, Betelgeuse will go off. Betelgeuse has been the subject of a lot of research since the 1st century BC. Recently, a scientist named Serafina Nance and her team tried to figure out when red supergiants like Betelgeuse might explode as supernovae. They did this to see how a star that big would behave over time. Nance and her team used Betelgeuse as a model for many scenarios. Then they compared their results to what they had seen in the field. Betelgeuse's brightness level dropped quickly and not in line with its normal cycle. It probably won't explode again for another 100,000 years. Betelgeuse was kicked out of its home in the Orion OB1 association, which is made up of the stars in Orion's belt. It has been seen traveling at 30 kilometers per s through the space between the stars. A bow shock that is more than 4 light-years wide is being made by the fast-moving star. After starting to dim sharply in October 2019, Betelgeuse had lost about 3 times as much light by mid-February 2020, going from magnitude 0.5 to magnitude 1.7. Betelgeuse had been steady in brightness for almost 10 days by February 17, 2020, and the star had begun to shine brighter again 5 days later. Though Betelgeuse didn't seem to be dimming at all, which meant that the dimming episode was over. Since there were no big changes in the infrared on February 24, 2020, it looked like the recent loss of visibility had nothing to do with the expected core collapse. That same day, another study found that the star's dimming was probably due to big grains of dust around it blocking light. A study using readings at sub-millimeter wavelengths says that dust absorption can't have a big effect. Instead, the fading seems to be caused by big star spots. Scientists are thrilled about the chance to see Betelgeuse's huge explosion and recovery, while the Hubble telescope keeps looking at the star. NASA's James Webb Space Telescope might be able to follow the Betelgeuse material as it moves through space. Thanks for watching the episode. Click the video on your screen to see more amazing space videos while you're still here.